The cosmic enigma unveiled. The secret atmosphere of a G-type star, specifically HD 61005. In the vast cosmic ocean, stars are the lighthouses guiding our understanding of the universe. Among them, G-type stars hold a special place, not just for their ubiquity, but for their striking resemblance to our own Sun. These stellar siblings offer invaluable insights into the conditions that foster life and the complex dance of stellar evolution. While the Sun remains our primary laboratory, observing other G-type stars, such as the intriguing HD 61005, allows astronomers to broaden their perspective and unlock secrets that might be hidden within our own solar neighborhood. G-type stars, our Sun's cosmic cousins. G-type stars are main sequence stars characterized by their yellow-white color and surface temperatures ranging from 5200 to 6000 Kelvin. They fuse hydrogen into helium in their cores, a process that typically lasts for billions of years. Our Sun, a G2V star, is the quintessential example. These stars are vital for astrophysics because they represent a critical mass and temperature range where planetary systems potentially harboring life can form and thrive. Their stable energy output and long lifespans provide the necessary conditions for biological evolution. Studying G-type stars helps us understand stellar dynamics, magnetic activity cycles, and the interaction between a star and its orbiting planets, offering a comparative framework for our own solar system. Unveiling HD 61005, a G-type star of interest. HD 61005 is a fascinating G-type star located in the constellation Carina. While not as famous as some of its stellar counterparts, it offers a compelling case study for understanding the diversity within the G-type classification. Stellar characteristics, spectral type. HD 61005 is classified as a G0V star, meaning it's slightly hotter and brighter than our Sun, a G2V star. Mass and radius. Its mass is estimated to be around 1.05 times that of the Sun, and its radius is approximately 1.1 times the solar radius, consistent with its slightly earlier G-type classification. Temperature and luminosity. With a surface temperature close to 5+900 Kelvin, it emits slightly more energy than the Sun, boasting a luminosity of about 1.2 times solar. Age. Determining the precise age of a star can be challenging, but based on its spectral type and evolutionary models, HD 61005 is estimated to be several billion years old, likely in the range of 3 to 5 billion years, placing it in a similar age bracket with the Sun. Distance from Earth. Located approximately 60 to 70 light years away, HD 61005 is close enough to Earth to allow for detailed spectroscopic analysis and direct observation by powerful telescopes. Its relative proximity makes it an excellent candidate for in-depth study. The secret atmosphere of HD 61005. The atmosphere of a star like HD 61005 is a dynamic, multi-layered envelope of gas and plasma extending from its visible surface far into space. It's not a secret in the sense of being hidden, but rather unveiled through sophisticated astronomical techniques, composition and structure. Like other G-type stars, HD 61005's atmosphere is primarily composed of hydrogen, around 75%, and helium, around 24%, with trace amounts of heavier elements often referred to as metals by astronomers, such as oxygen, carbon, iron, and neon. These elements are crucial for understanding the star's formation and the potential for planet formation around it. The atmosphere can be broadly divided into several layers. 1. Photosphere, the visible surface of the star where most of its light is emitted. Spectroscopic analysis of the photosphere reveals its temperature, chemical composition, and rotation rate. 2. Chromosphere, a layer above the photosphere characterized by rising temperatures and emitting a reddish glow, often visible during total solar eclipses in the case of the Sun. It's a region of intense magnetic activity. 3. Corona, the outermost and hottest layer extending millions of kilometers into space, reaching temperatures of millions of Kelvin. The corona is often dominated by magnetic fields and is the source of the stellar wind. Notable features: magnetic activity. Being a G-type star, HD 61005 is expected to exhibit magnetic activity similar to the Sun, driven by its internal dynamo. This includes star spots, cooler, darker regions on the photosphere, flares, sudden bursts of energy, and coronal mass ejections, CMEs. These phenomena are indicative of an active magnetic field, which can significantly impact any planets in orbit, especially their atmospheres. Stellar winds. HD 61005 emits a continuous stream of charged particles known as a stellar wind, analogous to the solar wind. This wind plays a crucial role in shaping the star's heliosphere, or astrosphere in this case, and influencing the space weather in its system. The strength and composition of this wind can be inferred from ultraviolet and X-ray observations. Coronal properties. X-ray observations are particularly insightful for studying stellar coronas. The emission patterns and intensity can reveal the temperature, density, and magnetic topology of HD 61005's corona. An active corona suggests a robust magnetic field, which is often linked to the star's rotation rate and age. Recent discoveries and observations. While specific groundbreaking discoveries unique to HD 61005 might not always make headlines for a star of its type, its study often benefits from and contributes to broader astronomical missions. TESS, Transiting Exoplanet Survey Satellite. Although primarily designed to find exoplanets, TESS data can provide crucial information about stellar variability, including subtle changes in brightness caused by star spots or pulsation. For HD 61005, TESS data, if available for this target, would reveal its photometric stability, offering insights into its magnetic activity cycle and potential for hosting transiting planets. Spectroscopic studies, high-resolution spectroscopic observations from ground-based telescopes like those at ESO or Keck observatories are fundamental. These studies analyze the starlight broken down into its constituent colors, revealing not only the star's chemical composition, but also its radial velocity variations, which can indicate the presence of orbiting planets. Furthermore, the shape and width of spectral lines can tell us about the star's rotation and turbulence in its atmosphere. Any unusual abundance patterns of elements in HD 61005's spectrum could hint at its unique formation history or interactions with surrounding material. X-ray observatories, e.g. Chandra XMM Newton. Data from X-ray telescopes would be critical for mapping HD 61005's corona. Intense X-ray emissions would confirm a hot, active corona, while variability in these emissions would indicate magnetic cycles and flaring activity. Implications for understanding G-type stars and life-studying stars, like HD 61005, provides a crucial control group for understanding our Sun. Each G-type star serves as a unique laboratory to test theories of stellar evolution, magnetic dynamos, and star-planet interaction. Diversity of G-type stars. By comparing HD 61005 with the Sun and other G-type stars, astronomers can assess the range of properties within this class. For instance, is its magnetic activity cycle more or less pronounced than the Sun's? Does it exhibit similar levels of stellar wind? Such comparisons help refine models of stellar activity and evolution. Habitable zone potential. Understanding the atmospheric properties, especially stellar flares and winds, is paramount for assessing the habitability of planets orbiting G-type stars. A highly active star might strip away the atmosphere of an orbiting planet, even if the planet is within the traditional habitable zone. If HD 61005 is found to have a relatively stable and moderate activity level, it could imply a more benign environment for potential life-supporting planets in its system. Exoplanet Search. Detailed knowledge of the star's properties, mass, radius, luminosity, rotation, is essential for accurately characterizing any exoplanets discovered around it. Without a thorough understanding of the star, the properties of its planets, like size, mass, and equilibrium temperature, cannot be reliably determined. Comparison with other G-type stars. When placed alongside other G-type stars, HD 61005 offers both commonalities and potential distinctions. While fundamentally similar to the Sun in its basic parameters, subtle differences can be highly informative. Solar analogs versus solar twins. The Sun is classified as a G2V star. HD 61005, being a G0V, is a solar analog, a star similar to the Sun but not identical. A solar twin would match the Sun's spectral type, age, metallicity, and activity levels almost perfectly. HD 61005's slightly higher temperature and luminosity suggest it might be at a slightly different evolutionary stage or have a slightly different internal composition compared to the Sun. Metallicity. Differences in metallicity, the abundance of elements heavier than hydrogen and helium, can significantly impact a star's structure, lifespan, and even its propensity to form planets. Any unique metallicity signature in HD 61005 could set it apart. Rotation and activity. A key differentiator among G-type stars can be their rotation rate and corresponding magnetic activity. Younger G-type stars tend to rotate faster and be more magnetically active. While HD 61005 is mature, its exact rotation period and activity level compared to the Sun could reveal insights into how these properties evolve over billions of years. For instance, if HD 61005 shows unusually high activity for its age, it could point to peculiar internal dynamics or tidal interactions with close-in planets. In conclusion, HD 61005, while perhaps not a household name, is a valuable cosmic laboratory. Its study allows astronomers to piece together the intricate puzzle of G-type star atmospheres, shedding light on the conditions that govern stellar evolution, magnetic activity, and the viability of habitable environments. Each observation brings us closer to understanding not only stars far away, but also our very own Sun and its pivotal role in sustaining life on Earth. The ongoing unveiling of stars like HD 61005 promises to continually enrich our cosmic perspective.